Example 3, we're going to use a graph to evaluate our piecewise functions. So we're going to, for the first one I'm going to do, and then the second one I'm going to do both of them actually because it's difficult to read this graph. So I don't know how well it's going to show up in the video. So for the first one, for part A, I need to find f of 2. So that means x equals 2. So I come over here, and then I find the function when x is 2. I'm going to be looking here. The y-coordinate is -1. So that's my answer. For part B, f of -3. So x equals -3. I'm going to come here. 1, 2, 3. That would be there. And then the function is not defined at the open circle. The function is defined at the closed circle up here, which happens to be between 2 and 3. So I'm going to say it's about 2.5. Part C, f of -1. So x is -1. It's going to be here. And at x equal -1, I see I've got this and I've got this, but they're both open circles. So it's not defined here. I'm just going to say it's undefined. There is no value that corresponds with x equal -1. Part D, f of -4. So x equals -4, so I'm here. I'm going to come find the graph. It's right there, and it is lining up with y equal 2. And then the second example on the right should be one for you to try, but I don't know if you can see it. So in this one, in part A, I need to find f of 0. So if x equals 0, that puts me here. I'm going to find the function is right there, and the y value is 2. F of -4 in part B, I'm going to find -4 on the x-axis is here. Now find the function, it's right there. The y value that corresponds with that would be 1. Part C, f of -1. So x is -1. I find the function when x is -1. So I see this, but I see an open circle. That's not the right spot. Come down here and I see a closed circle. So this is where the function is defined at -1, and the y value is -2. Part D, f of 3. So x equals 3. Function value is going to be here, and the y-coordinate is 3. In examples 4 and 5, we're going to be graphing. Okay. So first, let me darken my x and my y axis on here so they show up in the video. Okay, so I've got 3 pieces defined either greater than 0, equal to 0, less than 0. So all of the different pieces of the graph are going to be either on the right side of x equals 0 or over here on the left side of x equals 0. So what I'm going to do is I'm going to draw, even though I've got the y-axis, since the domain is changing around x equals 0, I'm just going to kind of darken it. I'm just going to highlight it with another color, just so that I can see that's where the pieces are going to be changing around that line. And I got that. I know that's happening because the domain is defined around x equals 0. That's where the breaks occur. So if x is greater than 0, the function is defined to be x squared. Well, this is when it's really useful to know that x squared is a parabola shape. Okay, so if I know this, that's really easy for me to sketch that in. So if x is greater than 0 on this side, it looks like this. Should be a little bit more of a curve. Okay, because it's one side of a parabola. When x equals 0, the function is 2, or the y is 2. So when x equals 0, I need a closed circle up here at 2. And because I've got this closed circle here, I need to put an open circle there. Because I have to make sure that my graph, since it's a function, I have to make sure that this graph passes the vertical line test at every point. So I have to have an open circle under that closed circle. And then the last piece, when x is less than 0, the graph is 2x plus 1. All right, so to do this part, I'm going to think about my y equal mx plus b that you did back in Math 1, probably in Math 2 also. The y-intercept is 1, so I'm going to start here. The slope is 2, so if I were to start at this point and go up to right 1, I would have a point on the graph. I could also go down to left 1 and get a point on the graph. And then I could go down to left 1 and get another point on the graph. All right, and then when x equals 1, that's where the y-intercept would be if I did this entire line. But because it's defined at this point, I need to put another open circle at 1. And then I can connect these dots with a straight edge. So this is how the function is defined when x is less than 0. It looks like this. So we have to make sure it still passes the vertical line test. So you see I've got all those open circles in there. All right, example 5. Okay. So let's look at the individual pieces. When x is less than 0, this is a linear one. And if I need it, I really should have a pencil so I can erase, but when x is less than 0, I'm going to be to the left of the y-axis. All right. Also, I see that the domain has a break. There's a break in the domain at x equal to 3. So I'm going to find x equals 3 on my graph. And I'm going to put a vertical dotted line through 3. Just so I can think of that as a partition between the different pieces. And I also need one at the y-axis when x equals 0. So I'm going to it's going to be doing one thing in this piece, one thing in this piece, one thing in this piece. Okay. So when x is less than 0, over here, I would have a y-intercept of 1. Let me darken the x-axis too, so you can see it better. So I would have a I would have a y-intercept at 1. I'm not going to darken that though. I'm just going to use it as a reference. The slope is -2, and I need to be working on this piece over here. So I'm going to go down 2, and then I can go right 1, or I could also have started from 1. I could go up 2 and left 1 because I have a negative slope. Up 2 and left 1. And then I'm going to connect these dots, making sure that it touches the y-axis at 1, because that's where the y-intercept would be. Okay, but x will not equal 0 here. It's only going to go up to this point. So we're going to put an open circle, but we're not going to color it in. In the middle section, this is when x is between 0 and 3, y equals 5. So anywhere in here, I need to find, let's see, 1, 2, 3, 4, 5. This is 5 on the y. So we're going to have, it's going to always equal 5. It's going to be a constant piece in here. It's going to be that flat line. And since it's defined when x equals 0, we're going to put a closed circle. And at 3, we're going to put an open circle. All right, and then for the last piece, when x is greater than or equal to 3, we're going to graph this -4x plus 14. Okay, now I see this has a y-intercept of 14, but it's hard. I can't really get that on here. But I'm going to try to kind of eyeball this, or you can also put in some points. What if we put in 4 for x? What would we get? All right, so I'm going to just put in some points. Well, if I put in 3, that would give me -12. So let's do a little table of values here. If x equals 3, so -4 times 3 is -12, plus 14 would be 2. if x equals 2, that's going to be negative 4 times 2 is negative 8, plus 14 is 6. Okay, so I can go to 3, 2, and this time I can put a closed circle because it is equal, x equals 3. And then order pair 4, 6, over 4 up 6. It's here, and I can connect those dots with a straight line. Okay, now there's one thing that I need to make sure it's clear on here. Where I darkened that line, I did that because it was the y-axis and I wanted you to be able to see it better, but you do not have a vertical line in this graph. So the actual graph would consist of this piece, and then it's got this flat piece, and then it's got this line over here, but there will not be a vertical line anywhere in the actual graph. Otherwise it would not pass the vertical line test. Okay, that should just be a dotted line there. Okay, that's example 5. Okay, and then let's take a look at this one. Okay, so this time, again, the first thing I do is I look at where the domain is, look at where in the domain that the definition changes. And I can see that there is a change occurring around the line x equal 2. Okay, so there's the y-axis. There's the x-axis, just so you can see it. And then when x equals 2, that would be here. I'm going to put a vertical dotted line to help me visualize the two sections of my graph. So there's going to be one thing going on the left of the dotted line and something else going on the right of the dotted line. On the left of the dotted line, the function is 5. So all I do is I find 5 on the y-axis. It's here, and I need to draw a horizontal line all the way through here up to that dotted line. Arrow, I need to do it a little bit darker than that though. Okay, there you go. And an open circle, because it is not, oh, it's equal, okay. X is less than or equal to 2, so it can be a closed circle. And then it shades all this back here. I'm just trying to make it dark enough you can see it. Okay? And then if x is greater than 2, that puts me on this side. And now the graph is going to be 2x minus 4. So I can do a little t-table and put in some numbers. If I put in 1 for 2, excuse me, if I put in 1 for x, that gives me 2 minus 4 is negative 2. Okay? But 1's not on there. I could kind of see where it would be. It would be about right there, but I can't really include that in the graph. If x could equal 2, where would it be? If x could equal 2, it would be 2 times 2 is 4, minus 4 would be 0. So that means I can put an open circle right here because the graph would touch there if it was defined at 2. All right, now let's put in 3. 2 times 3 is 6. 6 minus 4 is 2. So the order pair 3, 2 can go on the graph there. And if I put in a 4, 4 times 2 is 8. 8 minus 4 is 4. So order pair 4, 4 is here. And I can see that they're lining up. So I can connect these dots, but I have to make sure that I don't go past the open circle. Okay, so the graph is doing this constant function to the left of x equal 2, and then it's doing this line on the right side of x equals 2.